In this video, we're going to do some examples of evaluating logarithms. So we were asked to evaluate 4 different logarithms here without a calculator. The first one is log base 6 of 216. Well, log base 6 of 216 is 3. The reason for that, again, is remember we're looking for what exponent do we need to put on the 6 to give me 216. Well, the third power works for that. For part B, we're being asked to evaluate the log base 1/4 of 32. Now, in the previous example, we might have been easily been able to tell that 2 to the 16 is 6 cubed. But in general, that might be hard. For example, it might be hard to know what power of 1/4 gives me 32. So let's just call it x to start with. So I have log base 1/4 of 32 equals x. Rewriting this in its equivalent exponential form, this is the 1/4 is the base, the x is the exponent, the answer is the 32. So we get 1/4 raised to the x power equals 32. And now we notice that we can get both sides as a power of 2. Working on the left-hand side, 1/4 is the same thing as 1/2 squared. We can multiply our exponents to get 1/2 to the 2x. And then the reciprocal here, we can take the negative instead and make it 2 to the negative 2x. On the right-hand side, we immediately notice, hopefully, that 32 is 2 to the 5th. So we get down to this point where we have 2 to the negative 2x equals 2 to the 5th. Using the one-to-one property of exponential functions, we can equate exponents and get negative 2x equals 5, or x equals negative 5/2. So going back to the beginning, log base 1/4 of 32 is negative 5/2. In part C here, we're being asked to evaluate the log of 0.000001. Well, log, remember, is common logarithm, so the base is 10. So if I start with a 10 and I need to raise it to an exponent that gives me this 0.000001, I've got to do a negative 6 power. Move that decimal place 6 places to the left. And finally, to be able to evaluate natural log of 1 over the 5th root of e cubed, well, I can rewrite that 1 over 5th root of e cubed is e to the negative 3/5, so the negative 3/5 must be the natural log of that expression.